Alderson disk. An Alderson disk is one of the largest artificial structures ever proposed. Instead of building habitats on planets, an advanced civilization could construct a gigantic disk around a star. The star would sit in a hole at the center, while the disk itself could be billions of kilometers wide. Unlike a planet, the usable surface area would be enormous. In theory, trillions or even quadrillions of people could live on a single structure. Scientists find the idea fascinating because it pushes engineering to almost absurd scales. The disk would contain far more living space than all the planets in a solar system combined. If Earth were placed on such a structure, it would look tiny compared to the available land. The challenge is stability. Real physics suggests an Alderson disk would be difficult to keep balanced around its star. Even small disturbances could create major orbital problems. Building something this large would require dismantling entire planets and possibly multiple planetary systems. Yet, according to known physics, it is not completely impossible. It is simply unimaginably difficult. Dyson swarm. The Dyson swarm is often confused with the Dyson Sphere, but it is actually much more realistic. Instead of a solid shell surrounding a star, a Dyson swarm consists of millions or billions of satellites orbiting independently. Each satellite collects solar energy and transmits it wherever the civilization needs it. Over time, more collectors are added until a significant portion of the star's energy output is captured. A civilization capable of building a Dyson swarm would gain access to energy levels so enormous that planetary power grids would look insignificant by comparison. Some astronomers have even searched for unusual stars whose light appears partially blocked, wondering whether distant Dyson swarms could already exist somewhere in our galaxy. SHKADOV thruster. Most people assume stars are immovable objects, but a SHKADOV thruster proposes something remarkable, moving an entire solar system through the galaxy. The concept uses an enormous reflective mirror positioned near a star. One side of the star's light is reflected while the other side radiates normally. Because light carries momentum, this imbalance creates a tiny amount of thrust. The force is incredibly small, but stars live for billions of years. Given enough time, the thrust could slowly push the entire star and all its planets in a chosen direction. CAPLAN thruster. If the SHKADOV thruster is a gentle push, the CAPLAN thruster is a rocket engine for stars. Proposed by physicist Matthew CAPLAN, the concept offers a much faster way to move an entire solar system across the galaxy. The system would collect material from the star itself and use fusion reactions to generate powerful jets. These jets would act like exhaust from a conventional rocket, except the rocket happens to be a star. Additional structures would capture and redirect energy to maintain control over the process. What makes the idea extraordinary is its scale. Instead of waiting billions of years for small movements, a CAPLAN thruster could potentially accelerate a star much more efficiently. MATRIOSHKA brain. A MATRIOSHKA brain may be the most intelligent machine ever imagined. The concept involves multiple layers of computing structures surrounding a star, with each layer using energy from the one inside it. The name comes from Russian nesting dolls because the layers sit inside one another. The purpose is not transportation or housing, it is computation. A civilization might eventually value information processing more than physical expansion. By capturing most of a star's energy and converting it into computing power, a Matryoshka brain could perform calculations on a scale beyond human comprehension. NIVEN ring. The NIVEN ring is often confused with ordinary ring habitats, but it operates on a completely different scale. Proposed by science fiction author Larry Niven, the structure would form a ring around an entire star at roughly the same distance that Earth orbits the Sun. To put its size into perspective, the ring would have a circumference of nearly 1 billion kilometers. Its inner surface could support continents, oceans, weather systems, and ecosystems on a scale that makes planets seem tiny. From a scientific perspective, the biggest issue is stability. A ring world would naturally drift out of position unless advanced control systems constantly corrected its orbit. The structure would also need materials far stronger than anything humans currently possess. Black hole energy collector. Most people think of black holes as cosmic destroyers, but they may also be among the most powerful energy sources in the universe. A sufficiently advanced civilization could potentially build enormous structures around a rotating black hole and extract energy from it. This idea comes from real physics. Rotating black holes contain tremendous amounts of rotational energy. Through processes such as the Penrose mechanism, some of that energy can theoretically be removed. In simple terms, the black hole acts like a gigantic cosmic battery. The amount of available power is staggering. A single black hole could outperform the energy output of many stars. That makes it attractive to civilizations whose energy demands have grown beyond traditional stellar sources. Scientists find this concept especially intriguing because it is not merely science fiction. The underlying mathematics comes directly from general relativity. If you enjoy exploring the biggest ideas in space and science, consider subscribing and checking out more videos on the channel.